Let's go. And good afternoon, everyone. I'm Julien Garcia Gonzalez. I work for Giant Swarm, and thanks for attending this almost last sessions. I think it will be better like this because the scaling it's not proper. Oh. Yeah, let's do it like this. So first of all, who are currently using already Kubernetes? That's nice. And who are involved in security topics? That's nice. And who fight against the security teams in their company? Yeah. Okay, so I will try to help a bit of what you can do. But first of all, let's start with this one. Maybe some of you already know it. I'm really sorry for the resolution.
Hey! Hey!
So who already experienced that? Not everyone? Okay. So let's go over what we will talk today. We mainly talk about an overview of the tooling and around security. What is security mode, the passive and the active one. Then what is currently available in the open source world of security for the cloud native space. So we are really focusing today on Kubernetes, but much of those tools can be already used for also other components and not only Kubernetes. So first of all, there is two modes. The first mode is the passive mode. The passive mode is like conformance testing when you rerun your system as VM, bare metal machines, or even the cluster against conformance specification given by standard and so on, and try to make it conform to those things. The second thing is attack surface detection. That can be done also on passive mode, just checking the current system and seeing where you can attack it. And last part is the hardening. That it's a long way process where you will fill the gap on the security side on your applications and infrastructure. The other mode is the active mode. The active mode is pen testing, when you will run tooling that do penetration testing over the system that is on application, on the web server, on the infrastructure directly, and so on. Runtime attack analysis. That one would be checking what's currently running on the container, for example, in the case of Kubernetes, and check if there is something that is compromised inside your application, for example. And the vulnerability detection, that can be done, it's both parts, it's passive and active mode, but it's something that you can, on the runtime, found if a new CVE is released, found, you can get directly aware about wrong package in your applications. So to help on that, there is many tools, but yeah, but it's not really better, to be honest. Yeah, it doesn't really want. Let me try something quickly. But during what I'm doing that. There is mainly the active. Better. Now I see the same thing as you. But I don't have everything, but okay, it's still better. Okay, now we see everything. So there is the active and the passive mode, and also on the user side and the infrastructure side. So the talk is called Your Secure Journey on Kubernetes, and the way that I will explain is how from the ground, when you set up your VMs and your cluster, be secure from the ground, and then on top of it, you will add your application, secure the application during the deployment, and then when it's running, how you can detect that something is wrong. There is many tools for that. There was one that I had it on the slide, but I will not speak about too much today. The Sunobuoy, that it's a conformance testing application that is used currently with Kubernetes, for example, when Kubernetes community verified the certified provider, certified distribution of Kubernetes. So the conformance testing just run a test and provide a report about that. The first that we will go through, it's the CIS benchmark. Who is already familiar with the CIS benchmark? Okay, so the point of the CIS benchmark is 140 guides created by a cybersecurity expert that explain bit by bit everything that it can be configured properly on your cluster to be sure, cluster or application or such, to be sure that it's secure. And they provide benchmark for many tooling, and here we are speaking about Kubernetes, but there is many layers on the infrastructure, so it can go through the Kubernetes. So there is CIS benchmark for Kubernetes, for Docker, for AWS, for Azure, or for Linux directly. So the main point, when you set up your VMs and so on, running the CIS benchmark against the your VM, your infrastructure, would give you directly an overview of what is currently open, and you need to fix it. The great thing behind the CIS benchmark is that they're providing something like this, what it's currently checking, the rationale that explain more in deep what's the problem with that things, and also how you can audit it by yourself. So you have directly the command that you can run on your cluster or your server to be sure that everything is correct or not. On some rules, they also provide the fix and how you have to set up to fix the issue. But now we have the CIS benchmark, and we are engineers. We want to automate it, and we want to make that easier to do. Here I will focus on Kube-bench from Aquasec. That it's part of the full product, but that one is open sourced. And they will run directly the CIS benchmark for Kubernetes on the cluster. You can run it through a pod on the cluster, but also directly from the server and so on. The great thing that you will get with the CIS benchmark is it will check if your authorization and authentication is properly set up to and not opened. Check if the data is secure in transit between the components, and if the data is secure at rest for all the things that are currently stateful there. And also checking the privilege and seeing if there is root, a container running as root or currently running with privilege mode and so on, and report it. So it's a reporting tool. They are not doing nothing for you, but it will provide you the report and also what to do to fix it. So that is kind of the report that you can have. I will show you in the demo just after that. And now you have your benchmark run on the different layer of the infrastructure. You have your cluster running. Now you want to secure the cluster itself. And Kubernetes provides already a lot of feature for that. The first one will be RBAC, role-based access management control. That things, I will go in more detail after that, but the point is you will define which component will be assigned to a service account, so to a technical user kind of, and you will provide some roles to that one to specify, okay, that application can talk to that one, can have access to the endpoint, can have access to different components. That's the RBAC. You can also provide with RBAC namespace segregation with your user, specifying one team can have only access to one specific namespace and not to the other one, for example, with the Kube system and so on. There is per default two RBAC role, that it's the cluster admin and the restricted one. Then the second thing is pod security policies. So pod security policies, it's a YAML that you can run on your cluster, and you will define there security points for all the role belonging to that PSP. So, for example, what we can see here, if I check here, no, not the click, allow privilege escalation false, that means you cannot do privilege escalation inside your container. Or here, run as a user, must run as non-root. A lot of images that you can get directly from the Docker Hub and something like this are running as root. And that means being root in the container, it's being root on your OS system. By this, anything that will try to run as root will be kicked out by the API server. The next thing is the audit logs. The audit logs, it's like the audit logs for SSH or something like this. Everything that will be done through the API server on the Kubernetes will be logged, and you will see who did what when. And last bit is the network policies. And with network policies, you will be able to define policies between components in your cluster, service, pods, and so on the network level with IP ranges and ports. All those things are great. You have now your infrastructure kind of secure. You have your cluster with rules who can do what and to restrict the access. Now, what you want is to be sure that the application that will be deployed on your cluster is not vulnerable. Everyone is OK with the term CVE? Yes, kind of. OK, so a vulnerability that is found outside and it's in the package OpenSSL, and then you have to upgrade your package to be sure to not be vulnerable. There is a tool called Claire by CoreOS that it's open source too, that lets you analyze, static analyze the container for vulnerabilities. So it will check all the binaries, the file, and so on to be sure that it's secure. And how it does that? There is database, CVE database for Debian, for Ubuntu, and so on, with all the existing CVEs, with the versions and the fixes. And CoreOS just do a mapping between your image layer and the database. You can put it in passive mode, that is, you send the container and get the report. There is binaries that it's currently vulnerable, or also in active mode, that when a container was scanned, Claire will upgrade its database day to day, and then if it found a vulnerability or a fix in the already scanned binary, it can send you a notification saying that image that now can be fixed with that version, for example. If you want to run it, you can run it by yourself, but the great thing is it's when it's integrated with your registry, because that means every time you push the image in your registry, it's automatically scanned, and you can put different levels, saying I don't want to deploy an image that is that have a DEFCON 1 issue vulnerability into the container, for example. The two main registry supporting Claire per default, it's Quay.io, per CoreOS already, that have Claire inside. And so directly that you push an image, you have the report. And also Harbor. Harbor is an open source Docker registry that you can set up on your own cluster or on your own VM, and have Claire also set up inside. Now you have your application that it's not vulnerable anymore, and you are ready to deploy it. It's deployed on the cluster, and you want to check if your cluster is on the application level, and not only are quite reliable for the security. And KubeHunter will help you with that. So if I show you this, it's easier to get, but there is two tests, again, passive and active test. And the passive test will run commands directly on the cluster to check, for example, if the kubectl, there is a kubectl client accessible when you mount some volume into the cluster. It will do a port scanning and seeing which port are open. If there is a dashboard, Kubernetes dashboard, that are quite vulnerable, it will check if it's there and if it's properly secured. And it will give to you the report of that. The active test, it's like the GIF with exploding everything, it will directly try to kill something on the cluster, like DNS spoofing on the cluster, kubelet run trying to run random container on the cluster, trying to run a process inside the container, and things like this. And again, reporting what he was able to do. So for the kube hunter, you have 3 ways of running the test. The remote scanning, that it's from one laptop running the test against a public accessed cluster. The internal scanning, when you are on the cluster or on the machine running the test, what you can do when you have access to the cluster or to the machine. And the network scanning is that when you have access to the network, the full network of the company, what you can do at that place. So we have now pen testing our application, and we find some vulnerabilities. We try to fix it. But now, who already heard about the Tesla attack a few months ago? Okay, so Tesla run Kubernetes, and that was not really secured. And hackers try to have access, find a way to access the Tesla Kubernetes, and start running process inside existing containers. And the resource usage was growing really amazingly. After analyzing, they found that the hackers just run crypto money mining into the container of Tesla and using their resources. But from the outside, we didn't see it because it was the same application with the same metrics and everything. It was just another process that was not running with the PID 1 in a container. Falco, by Sysdig, is to find those kind of use case. Sysdig is a monitoring platform that uses syscalls to identify what's going on the cluster. So it's really a low level on the kernel. And Falco, that is part of the CNCF sandbox currently, do the same but for the security. So it's a rule engine that it's running between the initiation of the syscalls and the real execution on the kernel. There is a layer between, and each syscall that is run, it's passed by the rule engine, and then you have a log report about that. So they provide already a rich rule set to avoid common anti-pattern like the Tesla one, and also provide notification mechanisms through queue, like Kafka or something like this, or NATS. That is the rule that you can define. For example, if we check the first one here, disallowed SSH connection is to be sure that there is no SSH connection running on the cluster, and in a container or even on the host, because remember that every syscall that is run in a container goes through the host. So those components are running on the host, and everything that is on the host or in the container will go through the same rule engine. Or right below a binary dir, because we don't want anything writing in the binary dir in the container, because it's goal of the container to provide the immutability, for example. And what you can get is that kind of logs. If I take that one, it's what I just explained. File below a known binary directory open for writing. And then you get that. You get an error, and you can put that in your monitoring and find directly that it's currently running in that pod, Falco, GJ2, the demo event, with the user root, and so on. So you can see everything that it's currently really running inside your container, and you can define your own rules for that. The last tool that I would like to provide before doing the demo, it's the Open Policy Agent and more Gatekeeper. So Open Policy Agent is a policy-based control for the cloud-native environment. And the point is, everything that you do to Kubernetes goes through the API server. And so when you do a request, you can put in between admission controller that do the validation or mutation. So that means every request that you run through the API server will go through that webhook, and you can define something to check. For example, something that can be interesting for a security reason is to define which registry you want to allow on your cluster, to be sure that there is nothing from the Docker Hub that can be installed in the production namespace, but only from your own registry. That is the one. OPA, it's what I've said in the beginning. You can run that even for, it's a policy-based control. So you can run for everything, not only for Kubernetes. And it uses a language called Rego to define the rule. But in the Kubernetes world, we are using CRD and so on, and OPA came now with a tool called Gatekeeper that do the OPA things in the Kubernetes way with CRD for the policy definition and policy instance. And now I can give you some demo of that. So if I show you this, you see all the screen. That's perfect. So here we are in Kube-bench. I would like to show you RBAC and Kube-bench. So if I try now to deploy my jobs, so I have here the jobs to run Kube-bench on against the 1.13 Kubernetes version. In the namespace Kube-bench. The job is created, and what we can see here is that nothing is happening. Why? Let's check what's going on there. Yeah, here it's because it's trying to find the service account called this one, but that's not the one I want to show you. So if I create come on, create service account. Yeah, so now the service account is created. Let me delete the job and recreate it. Again, it's created and nothing happening. If I describe again, what can I get now? It's here. Can you see? Can you read a bit? So if you check here, host PID is not allowed. So Kube-bench needs to have access to the host PID to be able to run some host command to be sure that it's secure against the CIS benchmark. But by default, it's run on the restricted PSP, and that PSP doesn't allow running host path and host PID capabilities in the container. So now I have to enable the RBAC. So I have a file already ready for that. All those things will be on GitHub, and you will have access if you want to test it at home. So it creates everything. I will delete my jobs and reapply. Now the job is created, and we can see here that the logs, it's coming up. The pods, it's coming up. And if I show you the logs, it's what I've shown in the command, that you have the summary of the cluster itself, and also if I check here, for example, that one is failing, you have what it's problematic and how you can fix it. So you have everything that if the security wants you to fix your cluster, you can run that and then have a report and what to do and actionable things that you can do and plan already ahead. So that's nice things. The next things that I would like to show you, it's the clear one. So I have a harbor set up here and already push some images. And for example, if I take the Nginx ingress controller upstream that I push into Harbor, but it's the one that's coming upstream, there is 62 vulnerability and 4 that are already fixable. But currently the vulnerability at severity low, so that's why it's not really fixed upstream. And on the 62, there is only 4 that can be fixed. So if you check here, you have the report and also every CVE and also which version it's currently fixed in. So you can plan the upgrade and upgrade your images. Last thing that I would like to show you, and 5 minutes left, it's perfect, it's the gatekeeper. So imagine that the example that I've said, you have a staging environment and a production environment. On staging, you can run everything, but on production, you only want to run the images that came from the Arbor registry that I've just shown now. So let me show you. We have here deployed the CRD called I forget the name, it's constraints. So we have here a constraints template. Okay. Here, so that's the specification. The CRD, it's a custom definition, custom resource definition that you can put, and it will be treated as a Kubernetes object. And here, I defined into it regular rules that checking the repository, the registry of the image that you want to push, and just getting the registry itself and comparing that to a list to see if I can deploy it or not. So it's a rule engine that's saying yes or no. I will not go into detail of the things, I don't have time for that, but we can discuss that later. Now, what I will do, so that is the template. Template is, it's the rules, but not the value that I want. So now what I can do is to deploy the constraint that it's already deployed. And what I say here is that for an API group, so it's everything that's its kind of pod, like everything in Kubernetes have an API version and a kind, so that's those things. Here, everything that is a pod in the production namespace need to have the repo that is equal to that. You can define mainly for that one, for example, but here it's that things. So now what I will try to do, first I will try to deploy an Nginx container into the staging namespace. And the Nginx is coming from the Docker Hub. So staging good, Nginx pod created, and now we see that it's currently creating. So okay, it's exactly what we want. Now let's try to deploy the same things but on production. So the namespace is changed, but the container and the image, it's still the same, and it's coming from Docker Hub. But we expect that the admission controller managed by Gatekeeper will just kick out the requests. So now let's run these things. Okay, error from server. If you already played a lot with Kubernetes, you got that error from server a lot of time. It's what you try to do something against the API server, and the API server say, no, I cannot do this. But what we can see here is that the admission controller validation gatekeeper denied the request, denied by the name of the constraint that its prod repo is Harbor. The container Nginx has an invalid image, and providing the image allowed repo. Why I read that is the great things behind Gatekeeper is that you are providing the error that will be shown to your user. And that also kind of learning experiment, because beside being just blocking everything from production, when your user will try to deploy, they will get meaningful information of why it's not working and not just kicked out. And I find that really, really interesting. So now, what I would need to do, it's to deploy that, but for the Nginx, but from my registry. And now it's working. And the production is running. So here are the points. I'm part of Giant Swarm. We are providing managed Kubernetes cluster, and we take security as first-class citizen. It's really something that we are driven with, and we are providing a lot of upstream patches to allow PSP and RBAC that are not available on the M chart for that, for example. Thank you for listening. It was quick. I was really happy to do it, and it's already time's up for the question. It's pretty time's out, but I'm around if you have any questions. Thank you.